Before we go on, it is going to be important for us to know which probability model to use for a given situation. So I've made here a table to show us the different things that we've talked about. We've talked about Bernoulli, and our Bernoulli probability situation is when we have some success and a failure, and the probability doesn't change. And also, our events are independent. Oops, are independent. I don't know why the A dissipated. Independent. And these actually are going to apply to geometric and binomial as criteria. Now, basically, these require a Bernoulli situation. So our geometric model is going to tell us our successes after a certain number of tries. So how many we could expect to get or to succeed if we know how many tries that we have. Whereas a binomial model is going to tell us the chance for a certain number of successes after a certain number of tries. And in the formulas that are listed here, the letters don't really matter, but P represents our successes. Q, our chance for success, represents our chance to fail. And for the geometric, I'm using R to represent the number of tries that we take. I probably should have just used an N right there, but whatever. Over here, I'm using R to represent the number of successes that we want. And then N is the number of tries. And R, again, number of successes. P and Q, success and fail. And I've set up here a list of the mean, variance, standard deviation. But what we're going to focus on right now is knowing when to use these. All right, so let's take a look at a few examples. So first example, at the end of the school year, you are going through returned books to see how many are damaged. There's a 12% chance a book is damaged. So if you pull a book randomly out of a pile, there's 12% chance that that book is damaged. So how many books must you go through to find one damaged book? This is going to be a geometric situation. Geometric. So I am going to use the geometric formula, the mean formula, which is 1 over P. So that's going to be 1 over 0.12. And I won't bother pulling up my screen calculator for that. That's going to be 1 divided by 0.12. And I get 8.3. So about 8. You need to go through 8 books, basically, before you find a damaged one. Now, let's take a look at B. If you went through 30 books, how many do you expect to be damaged? So this one is going to be binomial because I want to find, if I went through 30 books, how many do I expect to be damaged? Yeah, that's definitely binomial because our mean is going to be NP. That's going to be 30 times 0.12. So 30 times 0.12 and get 3.6. So about 4 of the books would be damaged in that case. Okay, let's take a look at another example, keeping these things straight. Same setup, talking about books in the year, no change. So this is our P, so our Q is going to be 0.88. So what is the chance that there is a damaged book within the first 6 that you look at? This is a geometric situation. because we have a certain number of tries and we want to know, what's the chance that we get a success within that. So that's geometric. So we have this P Q to the 1 minus R. So 0.12 times 0.88 times, 6 minus 1. So we're going to put in 0.12 times 0.88 to the 5th. And I'll just go ahead and type that in. And I get 0.063. So there's a 6.3% chance that happens. If you went through 30 books, how many do you expect to be damaged? I actually just asked that. So actually, let's change this question. If you went through 30 books, what's the chance that, let's say, 5 are damaged? So now I've changed the question, and it is a binomial. So in this case, a success is a damaged book. So we're going to use NCR times P to the R Q to the N minus R. That's an R right there. Didn't come out too good. So 30, choose 5, 0.12 to the 5, and 0.88 to the 25. Okay, I will bring up the calculator for this one. And I will put in 30, choose 5, 0.12 to the 5th, 0.88 to the 25th. And we get 0.145. So there's a 14.5% chance that will happen. You have an unfair coin that lands on heads 25% of the time. So we'll call that our success, so 25, which means our failure is 0.75. How many times do you need to toss it before you would get heads? So this is a geometric situation. And that means I'm going to use this formula. So 1 over 0.25, which is 4 times. How many heads would you get after 20 tosses? So that is binomial. And that's going to be NP. So 20 times 0.25. And we will get, I believe, 5. Yes. Now, I didn't ask for a standard deviation for either of these, but the point for right now is to know whether the situation is geometric or binomial. Same situation, 25% of the time. What is the chance that you get a heads after 8 tosses? So that should be a pretty high chance. So let's see. This is geometric. So we're going to use this formula. 1 minus R. So 0.25 times 0.75 times, or to the 7th. So I'll type that in. Oh, well, look. It's only a 3% chance. Only a 3% chance. Well, I suppose that makes sense because you are getting 1 success. Okay. After 16 tosses, what are the chances that you get heads 16 times? This is binomial. So 16, choose 6 successes times 0.25. That's going to be 6.75. That's going to be to the 10. So I'll bring up the calculator for that one. So I'm going to type in 16 tries, choose 6 of them, 0.25 to the 6, 0.75 to the 10. And 11% chance. And I think that actually wraps up this section, but I'll just double check. Yep, that wraps it up.